Okay, what's up, guys? So we are giving this very first YouTube live a shot. Um, I wanted to just quickly cover a couple things before the exam tomorrow about displacement, velocity, and just solving problems in general. And I wanted to compare two different problems that we've seen in class to kind of make my point. Okay, so we saw this problem in class last week. It says Allison Felix runs all the way around a 400-meter track, and the question asks, what is her displacement? Okay, so delta x, right? That's what we're asking about. And so if we think about, a track, kind of like the one you see in the photo here, we were to sketch out that track, and she were to say, start here, and we call that x0, and she were to run all the way around and end back up right where she started, call that x final, and let's just say hypothetically that we're going to call that point 0 meters. Okay? Then we apply our equation, delta x equals x final minus x initial. And well, she started at 0 meters, and she ended at the same spot, which we just arbitrarily called 0 meters. And so 0 minus 0 gives us a displacement of course, 0 meters. So her displacement was 0. Why? Because she went all the way around and ended back up where she started. And so we saw this problem in class. There's nothing particularly tricky about this. There's nothing new. But I want to compare this with a different problem having to do with velocity. Okay. So there was another problem that has to do with a circular track. Problem 6 here on page 11. It says a car drives all the way around a circular 1,600-meter track in 100 seconds. What is the velocity of the car? And so many of you, applying the same logic from the Allison Felix problem, said, well, I have a circular track, and if I start here, and I drive all the way around, so that I end where I started, what is my displacement? And a lot of you said, well, my displacement has to be 0 meters, because I ended where I started. And so you wrote your velocity equation, delta x over t, and you said, well, my displacement is 0, and you took the time from the problem, 100 seconds, you plug that in, and you said my velocity is 0 meters per second. And you called it a day. Smiley face, and you moved right on. Okay? Now, honestly, this is not a bad thought. A lot of you guys, you were thinking about it. You were thinking about the fact that you were going around a circular track. You ended up at the same spot. But this is where we have to just think just a teeny bit harder. Okay? What does it mean to have a velocity of 0 meters per second? Okay? We have another name for this. If you have a velocity of 0 meters per second, it means you are at rest. And if you are at rest, you are not going anywhere. So if we look at the problem, the car drives all the way around the track. Well, how can you drive all the way around the track if you are at rest? Doesn't make any sense. Okay? So come to find out, your displacement was actually 1,600 meters. And now you're probably throwing your hands in the air and going, Mr. Nunez, what the heck? In the last problem, you just told me that you go all the way around, your displacement is 0. Now all of a sudden you're telling me it's 1,600 meters. And to some extent, I understand your frustration. Let me show you what I mean, though. Okay? So let's go ahead and erase all this. So erase. Okay. Let's draw our track more like an oval. just so you can really see what I mean. Okay, let's say here's our starting line again. And we call this X initial, and you start here, and you drive all the way around the track. And you get really, 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 really close, but you don't actually touch. Okay, you can see I've drawn it so that it doesn't actually touch. Super close. Okay. Well, until you get back to this exact spot, your displacement going all the way around this circle, well, let's say I moved 1 meter away, my displacement is 1 meter. I move another meter away, my displacement is 2 meters, 3 meters, and so on all the way around. Let's say I get halfway around the circle, it's in 800 meters away, 801 meters away. Keep going, till I get over here. 1598 meters, 1599 meters, and then right at the point, right here, just before you touch, you are at a displacement of 1600 meters from where you started. And so with that in mind, applying the logic that we just talked about, we want to know how fast we went. So I write my velocity equation, and I know I traveled a total of 1600 meters, and it took me 100 seconds to get there, and so my velocity was 16 meters per second. And this makes much more sense because I was in fact driving, and I was going around a circular track, and I was able to drive a total of 1600 meters, and it only took me 100 seconds. So that means that every second I should have been covering 16 meters. Okay, so I just wanted to show you guys these two problems right next to each other to show you the difference in solving those, okay? Now to prepare for the quiz tomorrow, you absolutely should make sure that you know all of these things. You should know displacement, distance, velocity. You should know position, okay? You should know their definitions. You should know their units, their variables. You should also know this velocity equation and this displacement equation, okay? And finally, make sure that you also know, this is page 9, the position time graphs, okay? You should know that if I take the slope, I get the velocity. Okay? If you guys have any questions, feel free to email me. That's all I've got. Bye.